Hello, let's continue our Sudoku adventure with Gimme Kropki by Pewterbleep. So this continues our a celebration for Adventure 1000, and this is inspired by a puzzle by GDC called Gimme Whisper. And this was on my list of my short list of puzzles that I would want to be inspired by. I didn't pick it, but Pewterbleep did. But it is an amazing puzzle. If you haven't tried Gimme Whisper, I would definitely take a look at that. Adventure 736. Pewterbleep says that puzzle manages to be very approachable and interesting with only 3 normal clues and very simple rules. It is one of the best examples of GDC's simple rules, simple rules, few clues, elegant solve puzzles, with which GDC always amazes me. GDC is an incredible setter, and we are very lucky to have him on this series. All right, well, let's go over the rules for this puzzle. We have normal 6x6 Sudoku rules, so in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We're also going to be placing a loop on the grid, a Kropki loop. So we're going to be drawing a 1-cell wide loop of orthogonally adjacent cells. So I'm actually going to, let's just see. This was back with the loop theme week where I had a really nice way of demonstrating that. But anyway, let's say this was the loop in green. You can see that it's 1 cell wide. And what's nice about, you could use the pen tool to draw it as well. Oops, not like that, but you get the idea. You could use the pen tool to draw it. But I actually recommend using highlighting because that actually helps you see that it is indeed 1 cell wide. Like if we tried to take this one, you could figure out a way to like draw a line to do that. I mean, that you can't go diagonally, but and it wouldn't quite look all that bad without the highlighting. But by doing the highlighting, you can immediately see that you've made a clump. So you're basically not allowed to make clumps. And additionally, the loop can't touch itself, not even diagonally. So for example, if I wanted to try to, let's say we had this loop, I couldn't do this because it's touching itself diagonally. Now, some argue, hey, it's touching itself diagonally there, but no, that's just how you draw the loop, right? You wouldn't be able to turn corners at all if that were the case. What we mean is you don't touch yourself diagonally outside of just taking a turn. So this would not be allowed. These would touch diagonally, and you'd actually have to continue here. But it's actually kind of hard to contrive an example in a 6x6 that touches itself diagonally. I had one earlier when we did the loop theme week. But anyway, now something like this doesn't work because it's not a loop. It's kind of branches off. So we need a 1 cell wide loop. Doesn't touch itself orthogonally or diagonally. Now, on this loop, which I guess I should draw, let's just draw a really simple circle here. On this loop, adjacent digits are either consecutive or in a 1-to-2 ratio. So basically we have to fill either a white dot or a black dot. So from this 1, we actually have to put a 2 next to it. But now from the 2, we could be consecutive. We could be a 1 or a 3, assuming we could have repeated that 1. Or we could be a 1-to-2 ratio, meaning 1 is double the other. So we could be a 4, for example, because 4 is double 2. So that's the basic idea. So all adjacent digits along the loop are either consecutive or one of them is exactly double the other. All right, and that is it. Those are the rules. There's a link in the description if you'd like to. Oh, sorry, that's not it. Oof. All the givens are on the loop. So we immediately know that all these 3 cells are on the loop. That's it. All right, now that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right, flubbed that intro a little bit, but let's get started. So I'm just going to green all 3 of these to say they are on the loop. Now, this 1 is interesting because we know the loop has to turn some corner. Like there need to be 2 cells next to the 1 that are on the loop. So 2 out of these 3 are on the loop. But we also know that the only thing that can go next to a 1 is a 2. Because the only digit consecutive with 1 is 2, and the only digit double 1 is 2. And you can't have the 1. Now, we can't put them both in the same column then, and we can't put them both in the same box. Or we'd be repeating a 2 in a box, or we'd be repeating a 2 in the column. And so there's actually only one way to continue from here, which is to take this one, which now excludes that guy, and then take this one. And so now I'm going to gray cells that can't be on the loop. So this one can't be on the loop anymore because it would make a branch. All right, now we know both of these are a 2. All right, now 6 is a little bit more open, but let's think about it. Next to the 6, we're going to need to put either a 5 or a 3. The 5 would be consecutive, the 3 would be half. So in the 2 cells that continue our loop, here and here, it's going to be 3s and 5s only. I'm not sure what to do with that. I wonder if the 2s continue. So we know this isn't on the loop either. So this actually has to continue. So it has to grow to here, and then from there it actually has to continue to here, and from there it has to continue to here. Now if we went down, there's an issue. If we went down, the only way we wouldn't be touching ourselves diagonally is if we finish the loop. And we'd be excluding these 2, which have to be on the loop. So we're not going to go down. If we went down and right, we'd be touching ourselves diagonally. So this is not in the loop, which means we have to go right again. All right, now from here, it looks like we have some options, but let's fill this out. So next to the 2, we could be a 1 or a 3 for the consecutive, but it can't actually be 1. And then if we halved it, it would be 1. If we doubled it, it would be 4. So it's a 3 or a 4. Now, next to the 3, 4, the 3 would have to be next to either it can't be the 2, so it would have to be next to the 4 or the 6. And the 4 would be next, so if it's consecutive, it would be next to a 3 or a 5. We can't have it to 2, we can't double to 8, so it would be 3, 4, 5, 6. Okay. So basically no 1s yet. Now here I'm not even going to bother. Let's see. How do we, so maybe this 2 needs to continue somewhere with a 3, 4. I don't know which way we're going. All right, is there more to think about here? Does this have to continue somehow? It could come all the way over here and come down. It could come down and meet it here. It could, we're not going to go down and then back up because then we get stuck. We can't form a loop in that case. So it's going to have to catch the 6 before it leaves the box, which I think it means it always leaves this way, doesn't it? So there's no way to catch this 6 and leave somewhere else. We can't leave the box and come back in to get the 6, or we make a clump, or we'd run out of room. So before we leave this box, we have to take the 6, and that means we're going to leave the box by going downwards this way. And so then this is a 3 or 5. 6 in this row is actually one of these 2. Definitely some options here. I don't know where we're continuing. What about this 6 here? So we're going to be coming down and grabbing the 6 in some way. And then we're going to leave the box. But we could leave this way. But, you know, we're gonna leave this box like this. And then we're going to come back into this box. And we're going to make a loop something like this. All right. There's only 2 cells next to this 2. They need to be either 3 or 4. Oh, we have some Sudoku. These 2s look down, placing a 2 here. So this 2 can't be next to the 6 on the loop. So this is not loop, which means that when we exit this box, we have to exit it this way and this way. When we exit it, we're going to exit this way. And this is going to be a 3 or a 5. Now we could go down. We could go up immediately. Yeah, I mean, we could even do something like this if we wanted. If we did something like this, we'd have to avoid touching. Or we could do, yeah, there seems to be a lot of options still. Is there any, oh, there might be some Sudoku here. Okay, we got a 6 here. Actually, yeah, 6 in this box goes here because it can't be next to the 2. And so now this is, okay, 3 is the only digit that can be next to a 2 and a 6. So that's our 3. And so then now the only digit next to the 6 is a 5 that's left. Now from 5 can't be part of a ratio. Can't have it or double it. So it's going to have to be the 4 or 6, but it's not the 6. So it's a 4. So actually I was just missing a bunch of Sudoku that could be done here. This is 1, 4. All right. Now next to the 4, we're going to be putting a 2, 3, or 5. This pair is 1, 2. So we could go 4, 2, 1, 6. That would, oh no, but one can't. Okay, so this isn't loop because 1 and 2 can't be next to 6, right? So if we took this one, we'd have to come down. In fact, this 6 has only 2 cells that can be looped next to it, so they both must be. So this is a 3 or 5. In fact, we know that this is also a 3, 5. Now, either of those could be next to a 4, or the 2 could be next to the 4. So we can go this way or this way, depending on how the digits resolve. But we don't, I mean, it would be nice to know whether we go down or right, but we don't necessarily have to know that yet. We're from 1, 3, 4. No, sorry. The 1 in this column actually can only go here. The 1's not in these two. So that's 1 and 4. And so then this is a pair. We need a 3 and a 4. And that means this is 5 and 6. Okay, so that's a 5. That's a 6. So this can't be next to the 2. There's no way. Oops, no, can't be next to the 2. So the 2 has to grow this way. Both 3 and 4 work next to a 2. Now we could come, okay, so we can't leave this box, because if we left this box, we'd have to enter this box this way, and we get stuck in order to grab the 6. So we have to come down, which means this one would make a clump. This one would never be. And also these are never a loop. Now these are just pairs. We need a 4, 5 here, and we need a 1, 3 here. One of these is a 2. 6 to the 3, 5. Oh, 6 can only be next to 3, not a 4. So that's 3 and that's 4. So these are from 3, 5, 6, and these are from 1, 2, 4. That's not a 4. So which way does this 3, 5 go, I wonder? We could definitely take a 4 here. The 5 would have to be next to a 4. The 3 could be next to a 2 or a 4. Or 6, but this can't be a 6. Over here, 5 could be next to 6. 3 could be next to 6. That's really it. So if we, oh, we can't go this way because of this turn here. Never mind. And so this loop does continue down here. So the 1 doesn't work. 1 doesn't work with 3 or 5, but the 2 works with 3. The 4 works with 3 or 5. Now, we could finish like this. We could finish even like this or like this. Is there any more Sudoku I might have missed? 6 is down here. Do we know this isn't loop? Yeah. We know this one's not loop. We could come down here. Oh, what's our next step? I am looking. I don't think anything can really be penciled in this last box. Not helpfully. This one maybe. It can be a 1, not 2. Could be 3, 4, 5. Can't be a 6. Yeah, that's not super helpful. 3, 5. Oh, this is a 3, 5 pair. That does it. So that makes this a 6. Makes this a 6. This is 3 or 5. A 3, 5 can't be next. Oh, sorry. I already graded that. Whoops. You got all these 3, 5 pairs here. It's a lot. Should I think about the coloring here? Okay, these two are the same as each other. These 3 are the same as each other. Unfortunately, I thought maybe we'd have a 3, 5 remote pair or something, but we don't. Okay, what about this? Oh, this can't be a 2. So the 2 goes here, and this is our 1. This makes that a 4 and a 1. Okay, so this is the 3, 5. This is 3, and this is 1. That makes this a 5, and that resolves all of these. The 3, 5, 3, 5, 3. That's 2 and 1. That's a 2. We get the 4 and the 5. Let's finish the loop before we finish the puzzle. So 4 can't go to 1. So 4 goes to 2. 2 can't go to 5. So 2 goes here. And it better be a 4. Okay. We got our loop as well. Very nice. Let's gray these out. All right. Oh, wait, hold on. I haven't finished my loop yet. Up here. 4, wait, I think, oh no, we can't touch ourselves diagonally, so it can't go here. That's been there. So we get the 2 there. Cool. Well, very nice puzzle, Peter Bleep. It definitely is reminiscent of GDC's puzzle, so that's good because that was the point. But yeah, it was interesting. So we got just the 3 givens. We were able to draw that loop in a unique way, and it solves the puzzle. I don't know how to, honestly, I don't know how to set stuff like this. It's very difficult to set. So kudos both to GDC and to Peter Bleep for being able to set something like this. I hope you enjoyed it, and if you did, then why not leave a like, subscribe, and a kind comment below.